rational exponents, and this is in direct relationship to the assignment 2.02 that is in your Module 2, and many of you are there, or you're going to get there, or you are already there. So I'm going to take just a few minutes of time and work through this with you. I'm not going to do each of the problems exactly the way they are. That would not be right, but I am going to do example problems that are exactly the same. This will only take a few minutes, and you can pause it if you need to. Now, let's take a look at question number 1. Is the expression equivalent to this expression, why or why not? Okay, so I need to familiarize you with a rule that says when you are multiplying exponents, you add the powers. Okay. When multiplying exponents, you add the powers. And that's exactly what we're doing right here. This is x to the 5th times x to the 5th times x to the 5th. We're multiplying these exponents, so I'm supposed to add these powers. So that means that in this example, this is going to be x to the 5 plus 5 plus 5, which is equal to x to the 15. Okay, so that is the value of this expression. Now, what is the value of this expression? Well, this is not that property. This is simply multiplication. X raised to the 5 times 5, which is 25, times 5, which is 125. So the question is, are these two expressions equivalent? Why or why not? No. X to the 15 is not equivalent to x to the 125th. And the reason for that is because in this first expression, we were multiplying exponents. In this second expression, there was simply one exponent, and we just needed to simplify. Okay, so hopefully that will help you. Again, that's not the exact problem, but at least it will help you to deal with the one that is very similar to it. The next question was rewrite in simplest radical forms this negative exponent. So what I'm going to do is I'm going to use a different negative exponent. I'm going to say negative 4 over 8. And I'm going to teach you how you're supposed to deal with negative exponents. Again, we have another rule. This is a rule of negative exponents. And the rule states that if you have a negative exponent in the numerator, then it must go down into the denominator of the fraction, and it will be turned into a positive power. For example, x to the negative 4 is simply 1 over x to the positive 4. Now, the same rule applies if you had a negative power in the denominator. So I'm going to show you how we apply this rule here. 1 over, okay, this is in the denominator, but that's okay. That doesn't mean that we can't have another fraction in the denominator. So according to this rule, this would be 1 over x to the positive 4 over 8. Okay, well, simply put, that means that my numerator is 1 over 1, and my denominator is 1 over x to the 4 over 8. Okay, so what you may see here is that we have a fraction divided by a fraction. So some of you may remember the rule there. Dividing fractions is easy as pie. You flip the second and multiply. So that means this is 1 over 1, this fraction, times x to the 4 over 8 over 1. Okay, dividing fractions. flip the second, and multiply. So that means that I'm going to have x to the 4/8 times 1, which is x to the 4/8 over 1. Now, pay careful attention to the directions. Rewrite in simplest radical form. Okay, simplest means we must reduce our fraction. 4/8 reduces to 1/2. Fine. Radical form? Okay. Time for another rule. X raised to the a over b power is equal to the b root of x to the a power. Okay. Now that right there is something you do not have written down in your notes. You want to put that in your notes. And you want to put this right here in your notes also. Okay? These are rules of how to deal with exponents. Now, the numerator goes with the variable. The denominator goes out here on the outside and is called the index. You may know that. You may not. I hope you paid close attention in the lesson. So if I'm supposed to rewrite this in radical form, the denominator goes on the outside and the numerator goes on the inside. So this is the square root of x to the 1 power, which simply means the square root of x. Okay, next question. Rewrite in simplest radical form. Okay, in this example, we are multiplying, except for the fact that we have a radical and a radical here. So I want to show you how to deal with this. Easiest way is to convert it from radical form into rational exponent form. Now, some people may not recognize that when you see the square root of x, really what that is an index of 2 and a power of 1. I'm seeing a lot of people make the mistake of saying that is x to the 1 over 1. Well, this is 2 because there's nothing written there, and it's square root. So the radical sign all by itself implies that you're dealing with a square root. So if my question said the cubed root of x, that would be x to the 1 over 3. If my question said the fourth root of x, that would be x to the 1 over 4. Remember, there's a 1 here, and the index is the denominator. That's that rule that I just showed you on the other page. X to the a over b is equal to the b root of x to the a. Okay. So in this example, and I'm not going to use this example because this is the problem, I'm going to use a slightly different example. I'm going to say, what if we had the cubed root of x times the 7th root of x? Very similar. Remember, up here in this example, there is a 2 there. How do I know? Because it's not written. So x to the 1/2. Now, in the example that I'm going to do for you right here, we've got our radical is 3, our root is 3, and our power is 1. Our root is 7, and our power is 1. So this is actually going to be equal to x to the 1/3 times x to the 1/7. Okay, so this is just like the very first question. When multiplying powers, you add the exponents. So this is going to be x to the 1/3 plus 1/7. Okay, fine. Now, we remember back from elementary school that if we are adding fractions, we must have a common denominator. So the common denominator, a common denominator between 3 and 7 would be 21. So quite simply, I could just multiply this fraction by 7/7. I could multiply this fraction by 3/3. That would give me 7/21 plus 3/21, which that would be equal to 10/21. Okay, so since I showed all of my work right here in this bubble, I think what I'm going to do is just go ahead and write down the simplified fraction. All the work is there. You must have common denominators when you're adding fractions. And then let's look and see. Rewrite in simplest rational exponent form. So at this point, all I need to check and do is see if 10/21 can be reduced. And there is no number that will go into 10 and 21, so the fraction 10/21 cannot be reduced. If that fraction could be reduced, then you would reduce it. But the question says leave it in simplest rational exponent form. And there it is. Now I want to warn some of you, I'm going to change my color here because I don't want you to think that this is okay. It is not okay for you to say, oh, that is x to the 1/3 plus x to the 1/7. That is not okay. You are not adding these two powers. You are only adding the exponents. And so therefore, if you're going to show your work, you want to be very careful not to make the work look like this, but instead to make the work look like this. And then showing your work for how to get a common denominator. Okay, let's go to the next question. Dividing rational exponents. So the example that was given, this is question number 4, they both had a common denominator. So I'm going to use a similar idea and use the same thing, a common denominator. X, let's just say 7/9 divided by x to the 2/9. Okay, that works. So when dividing powers, you subtract their exponents. These rules are very important. When dividing powers, you subtract their exponents. So this is going to be x to the 7/9 minus 2/9. Easy. Thank goodness we have a common denominator. If we did not, then it would be a little bit more cumbersome and we would have to get a common denominator, but we don't. So we can just say that this is x to the 7 minus 2, which is 5/9. Rewrite in simplest radical form. This is currently in rational exponent form. The question is asking for our answer to be in simplest radical form. Okay, so 5/9 does not simplify. That is, it's as simple as it gets. So the denominator becomes the index, and the numerator is the power of the radical. All right. Now, if that had been 6/9 for some reason, if we had a different problem and this had turned out to be 6/9, then you would reduce that first. 3 goes into 6 2 times, 3 goes into 9 3 times. Then you could rewrite that as the cubed root of x to the second power. But I think it is very important for you to know how to pronounce this answer. How would we read it if we were reading it aloud in a classroom or in a textbook? It would be read like this: the 9th root of x to the 5th power. Okay, so a lot of people will say that incorrectly, and they will say little 9 little square root thing. So I just have to let you know that's one of my pet peeves is, 9 square root x to the 5th. Well, that doesn't make any sense. This is the 9th root of x to the 5th. Okay, now I want to show you one additional thing that you're going to see. Question number 5 deals with all the different forms and how you're supposed to compare them. So I want to say, for example, if we had x squared times x to the 3rd times x, how would that simplify? Well, this is great because this is 1 2 3 and 1. So that is a total of 6 x's. So this is the 10th root of x to the 6th power. Now, that, if we rewrite it into rational exponent form, is x to the 6/10. Okay, look at that. We could simplify that. 2 goes into 6 3 times. 2 goes into 10 5 times. So that would simplify to that. And then if we were asked to write it in simplest radical form, the 5 denominator is the index, x to the 3rd. Okay. I hope that you have found that this will help you on the assignment for 2.02. This came in response to some concerns and questions about how to deal with rational exponents, and I hope that you find that this helps you. If it did, please shoot me an email